up, YouTube? My name is Johnny Bannon with Trepid Technologies, and today we'll be going over OSPF virtual links, which is part 3 of our OSPF video series. So click that link below to go to Trepid Technologies Confluence page, and let's get started. Alright guys, so let's bring up Confluence. Let's go to our OSPF virtual link configuration. So what is virtual link and why do we do it? So as we know in OSPF, all areas must be connected to the backbone area 0 right here. So we'll use this quick network diagram to show you a use case, right? Let me start this. So most network engineers, right, we try to create area 0 to be as large as possible, and then without any really specific documentation on it, when area 0 gets too big, we create non-backbone areas. We do this to try to save resources on our routers, because creating a link state database for a backbone area of 100 routers can take up a lot of resources. So then we create these non-backbone areas. So what if, as network engineers, we fall into a network that looks like this? Where now our company has taken over an office in Detroit and Chandler, and our Miami router, which is an end device on area 40, is the cheapest and best connection to Detroit over here. But Detroit may already be part of area 50, and then another backbone area over here, when its old network engineers gave it over to you. So now we have an issue where we can either make this a part of area 40, and we're going to see some outage, or we can just create a virtual link to connect this router to area 0. So we do this by creating a virtual link. So essentially what we do is trick the ABRs R4 and R5 into believing that R8 is part of area 40, okay? So this may sound confusing, right? But like I say here, if we remember our fundamentals, all areas must be connected to the backbone area. So if we make area 0 believe that the routes coming from R8 are in area 40, then technically those routes are valid because area 40 is connected to the backbone area. So again, we have to trick the ABRs, right? We do this by creating a virtual link, and the virtual link is between R5 and R4. So remember that, guys. When doing OSPF virtual link, you do it between ABRs. R5 is considered an ABR because it's between area 40 and 50. And R4 is considered an area border router because it is between 0 and 40. So this virtual link works by flooding type 1 LSAs in area 40, and then the ABR R4, right, which is between area 0 and area 40, will now know the routes in area 50. So essentially what happens is R5 in that virtual link makes these routes believe that they're a part of these areas. So once the backbone area router knows the routes from area 50, both ABRs will create a tunnel. Then once those tunnels are created and established between both ABRs, the ABR that's connected to area 50, which is R5 right here, is going to create type 3 LSAs, right, for all the networks that this R8 and area 50 is advertising, and it's going to get flooded into the backbone area. So now the backbone area router will believe that these networks are in the adjacent area, area 40. So if that's a lot of language, guys, it just sounds foreign. Essentially, all we're doing is tricking this router and this router into believing that these routes are actually a part of area 40 right here, okay? And we do this by creating a virtual link between ABRs. So now let's do the how-to, right? What we came here for. So again, guys, my first step is always to set up GNS3 and to put a baseline. So we're going to be working between R6, R4, R1, R5, R8, and R10. Actually, I don't think we might not use R10, if I remember correctly. So this will be our area 0, R6, R1, R4. R4 to R5 will be our area 40. Then R5 to R8 will be our area 50. And maybe R10, I can't remember exactly what I did. But you see this baseline right here? When I made this, it was maybe 3 to 4 or 5 weeks ago. My baseline has changed, and it constantly changes as I go through more labs, right? As I try to tweak and tune my lab environment to work for me. So what I use is GitLab to actually host all my baseline and all the files I use to manage my network. You can clone this repo using Git, coming to VS Code, doing a Git clone, then opening up this folder right here, right? So I've already done that. And if you don't know how to do that, refer to my other videos, guys. And let's baseline our routers. And again, when I use that term baseline, right? In our lab environment, what I'm doing is just setting all the routers to have IP addressing, right? And some housekeeping commands. So this is what a baseline would look in a lab environment. A baseline in production should be a configuration that gets the router or the switch or the network device up and running and ready to be used in the enterprise, okay? With that being said, let's open up GNS3. Again, I'm using Ubuntu, so we do things from the terminal, right? Like all good Linux users. Wait for these routers to load, and let's start our network. So what I'm going to do here is take this to the side, and I'm going to follow this how-to step by step. And once we got our GNS3 environment up and our how-to page over here on the side, let's start doing some configuration. So again, first thing we got to do is baseline. So I'm going to go through and baseline all the routers we're going to use. I'm going to start with the area 0 routers. Okay. Four, 6. And guys, if you're on a Windows machine or if you know of a better terminal emulation program to use in GNS3, one suggestion is Secure CRT, where I don't actually have to have 3 different terminals up. It can just be tabbed out in one terminal, right? It makes your labs a lot easier when working with this many devices. I've tried installing Secure CRT and it didn't work like I wanted to. It couldn't integrate into GNS3 well. I'm sure there's a way, but for now I'm just going to use the GNOME terminal. Okay, so first things first, I'm going to run some applets that baseline my routers. Again, baseline in the lab environment means getting rid of any routing process. So we can have a clean slate and the interface is going to have IP addresses for us to actually set up some routing and implement technologies. Okay, so here in R6, I'm going to shut down gig 01 because I want a clean network. I don't want any outside connections. And then R1, I'm going to shut down gig 01 and the actual physical address there. First, I'm going to do show IP interface brief up. I'm going to shut down the tunnel and the MDMA address, so gig 02 and tunnel 0. So interface range gig 02, tunnel 0, shut. And I do this because these other routers, when I load them up, are running Ospf, and I don't want all these other networks getting advertised into what we're doing for this lab, which is just R6, R4, R1, and then R5, R8, and R10, okay? So again, this is just blank, so the network diagram, guys, if you want to download this, you can, and just bring it up to the side as well and make it a little easier so you know what areas we're working in. Let's go back to what we're doing. So we got our baseline, right? So there should be no router processes running. Do show IP protocols. Nothing. And we should just have some basic IP addressing, okay? Great. So now, let's go to R6 and R1, and let's configure them for area 0. We're going to do this under the routing process, okay? So instead of doing it under the interface, which we can do, we're going to do it under the routing process. We're going to hard code some router IDs. Then we're going to advertise all of our active networks into area 0. Do this on R1 as well. Router Ospf1, router ID 1.1.1, network 155.1.0.0/16 wildcard mask. Easy stuff, right, guys? All right, and now we're going to configure the ABR router 4 between, and again, it's the ABR for the backbone area and area 40, a non-backbone area. So we're going to configure Ospf on the interfaces here. I do this when I have ABR, so it just makes more sense in my head, right? I'm saying, hey guys, these interfaces are going to be in this area instead of doing the network command. But either way works, right? With the network command, you just got to be a little bit more specific on your network statement. So instead of doing a /16, you would have to do whatever the subnet mask is for those individual interfaces, which is fine. And then on Seattle router, I'm also going to shut this interface right here, because I don't want my DVPN network advertising anything as well. Okay. So see all those changes. I have a lot of PIM changes. Don't worry about that. Now let's go to R5. Okay. So on R5, we're gonna purposely create a discontinuous network. We're gonna put it a part of area 40, and then create another area 50, which breaks the rules about having all areas connected to the backbone area. We'll do this and then fix it using a virtual link. So on R5, I'm going to do it under the interface and under the global routing process. So what I'll do is set a router ID, 5.5.5. First baseline, right, guys? Of course. So now we're going to baseline this ABR. And then we're going to go in and shut any interface that we're not using for this lab. So that tunnel interface, or we can just do the MBMA interface. So we'll do the MBMA. And now let's do Ospf. So we're going to do area 40 under the routing global process. So this is what I said earlier, guys. When you have an ABR and ASBR and you want to do it under the routing process, you got to make sure your wildcard mask and your network statements are accurate per that interface. For example, this loopback that I'm about to advertise in here is a /32 subnet. So my wildcard mask is going to be all zeros. So here we have a physical interface and a loopback being part of area 40, the non-backbone area. And now we're going to set up what I like to call our discontinuous network. So the non-backbone area that doesn't connect to the backbone area. And we're going to do this under the interface configuration. Okay. So now if we do show IP Ospf neighbor, we see that we're neighbors of R4, the other ABR. And we're getting this error message from R8, and that's okay because we're going to go fix it right now. Now let's get into R8, and the first thing we're going to do is baseline, right? Set up interfaces. And then what I'm going to do is shut the port going to R10 Again, so we don't get some mismatch area IDs. Remember, all my routers run OSPF right when I load them up. So we're going to do that. And now we're going to go under the global routing process and configure this router to be under area 50, which is a discontinuous network. So when I do this, area 50, none of these routes from R8 should be seen in the backbone area, or in area 40 for that matter. So it did create a neighbor of R5, but now let's go back to R4 and see if we see anything from R8, which we shouldn't. Do show IP route OSPF. This is coming all the way from R6. Guys, before I go on, I'm going to make sure that R4's tunnel is down. I'm going to make sure R1 and R6, because it looks like we're still getting routes from over here, and I don't want that. I want a clean lab. I'm going to make sure everything's shut on R6 and R1. That needs to be. Clean this up a little bit, get this out of here. After this, guys, we'll just be working between R4 and R5 to create that virtual link. This right here I need to shut on R1. Because that's bringing in all the routes from over here on our network, R7 and R9. We're going to shut that. Then we should see a clean lab, okay? So now let's go back to R4, R5, where we're going to be creating the virtual link. R5, R4. Bring these guys up. Let's clear it. Let's regather what we're doing here, okay? So again, if I bring this Confluence page up, I'm going step by step. But what we're doing is we have a discontinuous network right here, area 50. And we're doing a virtual link between R5 and R4. So that these routes that R8 are sending to R5 can be put into the backbone area, okay? Essentially, we're tricking this backbone area into thinking that these routes are a part of area 40, okay? So with that being said, bring this to the side again. Let's create our virtual link. So something to know with virtual links, right? We do them on both the ABRs. And we're going to do it using the router ID, okay? So let's get our router IDs. So how can we do this? So to look at the router IDs, we have a couple different commands. We can do show IP OSPF neighbor. And we can see the neighbor ID for R5 is 5.5.5.5. And then we can do show IP OSPF interface, gig 02. And we can see our router ID is 150.1.4.4. On R4, we didn't statically set a router ID, so it chose the highest loopback address. So now let's configure this virtual link. So what we do is go into the global routing process. We're going to type in area 40, right? Because that's the good area. That's the area that's not discontinuous, that's connected to the backbone area. And we're going to say, hey, area 40, I need you to create a virtual link with your neighbor, router 5. Router 5 is the one with a discontinuous network attached to it. And then we're going to go into router 5 and tell it the same thing. Hey, I need you to make a virtual link with the ABR that's connected to the backbone area, which is R4. And once we do this, we should see a syslog message that's saying OSPF underscore virtual link 0, okay? Now that we have that, I'm going to bring up R4, R5, and R8, right? All of our ABRs and then our discontinuous area router And we're going to do some show commands, okay? So R4, when we do show IP OSPF neighbor, we're going to see 4 neighbors, which is crazy. Let's see, this neighbor 1.1.1. And with 6.6.6. Okay, what we need to focus on here is that R4 has a DR and BDR relationship, right, with area 40 and area 0, the broadcast networks. And then it has this virtual link with router 5. And this virtual link is how it's learning about the routes from R8. So now if we go to R5 and do the same, we essentially have the same thing, okay? We have a DR-BDR relationship between both the areas we're connected to, area 40 and area 50. And then we have this virtual link of R4 that's going to be sending all the routes we learned from this discontinuous area, area 50, between R8. Then R8, we should only have one neighbor, and that's the router 5. Now if you look at the show IP OSPF database, we know that databases have to be the same in OSPF, right? So let's see what we got here. That's the virtual link right there. If you actually look right here, these are links from the virtual link, what that DNA stands for. Let's run the same command over here. We can see that in this link state database, we actually have area 50. So even though the rule is that our link state database is supposed to be the same across all OSPF routers, we see between R4 and R5 that's not the case. And that's not the case because the virtual link that we set up, right, is tricking R4. Now if we do the same thing here, we just see area 50 here, okay? Now moving on, let's go to the actual routing table. Show IP route, OSPF. We can see that the routes from R8 are just considered inner area routes, okay? Just type 3 LSAs. Go to R5, do the same thing. We don't have any inner area routes because R5 doesn't consider this inner area because it's connected to it. And it doesn't consider the backbone area routes to be inner area either, okay? Now if you look at R8s, all we should have is inner area routes. Because when R5 advertises all the routes to R8, they're all coming from an area it doesn't know about, that it's not directly connected to. Whew, all right guys. Now I know that virtual links may seem hard, but at the end of the day, all we really care about is that we make that connection between AVRs so that these routes can be propagated and advertised to area 0. All right, so from everyone here at Trevor Technologies, I want to thank you guys for viewing, and remember to keep learning every single day.